Hi, welcome to Muqaddimah. My name is Savish. A while back, I was doing what people do on Twitter, arguing with people, and I saw a post about how radiocarbon dating the earliest Quran manuscripts proves that the Quran existed during the lifetime of Prophet Muhammad. In fact, the range of some manuscripts starts before the Prophet was even born. So, did the Quran exist before Prophet Muhammad? No, of course it didn't. There's no real evidence to support that. However, people seem to think that radiocarbon dating is an objective end-all way of telling when a historical object was created, and that's simply not true. It's just one of many tools that are used when it comes to historical studies. So today, we're going to talk about radiocarbon dating some of the earliest manuscripts of the Quran and how relying on just radiocarbon dating might not be the best idea. Before we begin, let me tell you a bit about what carbon-14 or radiocarbon dating is. There are three isotopes of carbon that exist naturally on Earth: carbon-12, carbon-13, and carbon-14. Carbon-12 is stable and makes up around 99% of all carbon on Earth. Carbon-13 makes up around 1%, while carbon-14 makes up a very small percentage. There exists one atom of carbon-14 to every 1 quadrillion of carbon-12 and carbon-13 atoms in the atmosphere. That's 1 followed by 15 zeros for every 1 carbon-14 atom. Now, all living things have both carbon-14 and carbon-12. The ratio of carbon-14 to carbon-12 in a living being is the same as its environment because our bodies interact with the environment. If nothing else, we eat plants that, work through photosynthesis, etc. However, when a living thing dies, the amount of carbon-14 in its remains starts decaying thanks to radioactive decay. In 5,730 years, half of the carbon-14 in the remains will be gone. It'll have become nitrogen-14. In another 5,730 years, 75% of the original amount will be gone, and so on and so forth. So let me give you an example. Let's say that in the year 600, the carbon-14 to carbon-12 ratio in the atmosphere was this. A sheep died at that time, and its skin was used to make parchment on which a part of the Quran was written. So the ratio of carbon-12 to carbon-14 in that piece of parchment would originally have been the same as its atmosphere at that time. By the year 2000, 1400 years after the sheep's death, we would expect around 15.579% of the carbon-14 to have decayed. Hence, the ratio in the piece of parchment in the year 2000 would be this. That's oversimplified, but I hope it gets the idea across. So this is how we can determine how old a piece of organic material is. However, we do have to know what the ratio of C14 to C12 at the time of its expiration was, and that is not an easy thing to determine. There are way too many factors that decide how much C14 is in the atmosphere. So many that all the considerations for radiocarbon dating have their own Wikipedia page. The amount of solar activity at any given time can change the production of C14. So can things like climate cycles, human activity, and whatever hemisphere the source happens to exist in. The amount of water around the location of the source is also a factor because the ocean dissolves carbon dioxide in the atmosphere as well. In the case of parchment, which, like I mentioned, is made from animal skin, the diet of the animal can also impact the amount of C14 in the parchment. So there are quite a few things that need to be considered when trying to determine the amount of C14 in the atmosphere at any given time. One of the ways to determine the level of C14 in the atmosphere at a time is to find something that we know expired around that time and just testing the amount of C14 in that. One of the most important resources for that is tree rings. Tree rings tell us what the exact conditions at the time of the tree ring's formation were like and help us calibrate radiocarbon dating. This has resulted in the compilation of an extensive data set that's used to determine what the C14 levels were like at various points in history. Tree rings are just amazing. They're like snapshots of their environment at a particular time. That all sounds deceptively simple, but it's really not. Imagine trying to find a tree that existed in the year 600 CE and then analyzing its rings and checking the C14 level of the rings formed around that time. Even if you do that, there's many other complications. Let's say you found a tree that existed in 600 CE, but it's all the way in Ireland because of course it is. The hotter parts of the Middle East don't have that many forests after all. Can you apply what you learn about C14 levels from that Irish tree to parchment that was produced in the Middle East? The Middle East and Europe have very different climates, geography, etc. Like I mentioned before, quite a few localized events and factors can impact the amount of C14 in a region, but you might say that because of the Earth's atmosphere, air moves around a lot, and perhaps it's fair to assume that over a decently long period of time, C14 levels should be averaged by the atmospheric circulation of wind. However, the northern and southern hemispheres of the Earth are rather independent of each other when it comes to the circulation of wind. So the C14 levels in the southern hemisphere can be different than the northern hemisphere. So let's say that because of this, we can actually assume that the C14 levels in Ireland and Mecca in 650 CE were the same. Both are, after all, in the northern hemisphere. It should work out, but it doesn't quite neatly work out. There's something called the intertropical convergence zone. Okay, let me simplify this. Basically, there's an equator that's geometric. We draw it right in the middle of the Earth. But there's also an equator known as the thermal equator. Like I previously said, the atmospheric circulation of the hemispheres are pretty much independent of each other. Well, the thermal equator somewhat marks the boundary between them. Unfortunately, that equator moves throughout the year. In July, the boundary looks something like this, while in January, it looks something like this. You might be seeing the problem. Places like East Africa, the Arabian Peninsula, India, and East Asia move between the hemispheres. So for half of the year, they're part of the northern circulation of wind, and for the other half, they're part of the southern circulation. The southern hemisphere has a lot more ocean than the northern hemisphere, which exchanges carbon with the atmosphere. This ocean factor is such a major point that the same level of C14 can mark a difference of 40 to 50 years between the hemisphere. Meaning if we find X amount of C14 in a piece of parchment from the southern hemisphere, it will be 40-ish years younger than a piece of parchment with the same level of C14 from the northern hemisphere. Now, Islam was born in Arabia, and the earliest Quranic manuscripts were also written in Mecca or Medina or somewhere nearby. Arabia, as I mentioned before, changes hemispheres, so the level of C14 can change quite a bit. We cannot trust data taken from trees in Ireland or Germany or the United States to provide good calibration for organic material produced in Arabia. Nevertheless, the calibration database of C14 dating is constantly being updated with new discoveries, and previously collected data is calibrated again and again. Hopefully, this will continue and we'll keep getting more and more accurate data. So that was a simplified explanation of how many things have to be considered when it comes to radiocarbon dating a Quranic manuscript. So with that considered, let me tell you a bit about the traditional narrative of how the Quran was compiled. If you already know this part, you can skip to the next timestamp. So the Quran was revealed to the Prophet Muhammad, who used to hear it from the angel Jibreel or Gabriel. Muslims believe that the Quran is the verbatim word of God, so it was very important to store it as it was. As a result, the Prophet used to dictate it to his companions, some of whom would write parts of it on leaves, rocks, bones, parchment, etc. However, the primary medium for the storage of the Quran was the memories of the Prophet's companions. When the Prophet passed away in 632 CE, his small state, which was held together by the Prophet himself, began to shatter. At that point, conflict ensued as distant tribes began to break away from their oaths to the Prophet, and so his successors, the Rashidun caliphs, had to bring them back under their fold by force if needed. This led to battles in which many companions of the Prophet died, and with them their knowledge of the Quran. So the Rashidun caliphs began to worry that this could have an impact on the storage of the Quran, and so under the third Rashidun caliph, there was an effort to compile the Quran. By the time of the third Rashidun caliph, Uthman, Islam had spread out of Arabia and taken over Syria, Palestine, Egypt, Iran, parts of Central Asia, and parts of Tunisia. Arab Muslims lived in separate garrison cities called Amsar, where they lived away from the local natives who, of course, weren't Muslim. These various Amsar, like Basra in Kufa in Iraq and Fustat in Egypt, began to develop their own identities, including how to read the Quran. Since the Quran was largely oral at this point, there was no universal method to it. People read it in different methods and even had disagreements over words, which could have been a big deal. So there was a need to store the Quran in a physical form and make it universal to end all these local versions. The third Rashidun Caliph, Uthman, began this project by assembling a committee of companions to write down the Quran and compile it into a book form. He finished it around 650 CE when he sent his copies to the various cities and ordered the destruction of all variants that didn't mean the Uthmanic standard. This project was actually very successful. There's only like 2 or 3 Quran manuscripts in existence that aren't fully Uthmanic. So the universal standard set by Uthman put its roots down all over the Islamic world, just 2 decades after the death of the Prophet. However, there's disagreements over this narrative. There are scholars who believe that the Uthmanic standard of the Quran was not universal and was merely one of many local variants, and that it was actually the Umayyad Caliph Abdul Malik ibn Marwan and his governor Al-Hajjaj ibn Yusuf who standardized the Quran around the year 700 or so. I'm not gonna talk about that in this video. We'll just talk about the earliest manuscripts of the Quran, so let's get to it. Previously on this channel, I made a video about the Sana'a manuscript. It's a part of a large collection of documents found in the Great Mosque of Sana'a in 1972. The famous Sana'a manuscript is actually called DAM 01-27.01, also known as the Sana'a palimpsest. Palimpsest is a document which has a text that was erased and overwritten with something else. In this case, someone wrote the Quran on parchment, which was later removed and rewritten. What's interesting is that the newer layer conforms to Uthman's standardization, while the older layer doesn't. In my previous video, I mentioned that they were radiocarbon dated with 95% probability to between 578 and 669 CE, with 75% probability of before 646 CE. This would put them remarkably close to Uthman's standardization. But when samples from the same manuscript were tested at another lab, the results were radically different. 3 folios dated to even before the Prophet was born. The third of these folios was tested again at another lab, and it gave yet another radically different set of results. Many scholars have speculated on the reasoning, but there's no real answer. We simply don't know. There could have been contamination, weather damage, or a number of different factors. For example, some of the folios were being stored in the ceiling of the Great Mosque of Sana'a, which could have exposed them to centuries of water from the rains and heat from the sun. Sana'a also switches hemispheres. It's near the Indian Ocean. It sits at an altitude of around 2,200 meters. All of these are important factors, and there are simply too many factors to consider. Also, it could even have been just good old human error. While these labs are prestigious institutions, they are run by people, and science isn't always objective. Some scholars have pointed out that scientists who radiocarbon date organic material from Europe must be trained to study organic material from the Middle East, simply due to their different climates. The original paper by Behnam Siddiqui and Uwe Bergman theorized that based on radiocarbon dating, the Sana'a manuscript was likely produced within 15 to 30 years of the death of the Prophet, but other scholars of the Quran have dated it to the late 7th and early 8th centuries based on the style and markings. But ultimately, the date of this manuscript has proven quite difficult to pin out so far. Work is still being done. In 2014, the University of Tübingen in Germany had an early manuscript in their collection tested. There was a 95% probability that the animal that the folio came from died in between 649 and 675 CE. This would make the Tübingen Quran one of the oldest Qurans in existence, with only the Sana'a manuscript even close to its age. But the manuscript has been dated by scholars to around the early 8th century, based again on the markings and the text. That's some 50 to 70 years after what the radiocarbon dating suggests. What's really interesting about this manuscript is that the three folios' age is quite different from each other. If we take the results at face value, then one of the folios has been dated to between 605 and 669 CE. The youngest of the folios is dated almost 70 years younger than that one. We have to go by at least the date of the youngest folio in the manuscript. This could mean a number of things for the overall study of early Quranic manuscripts. First, this shows that it was possible for a piece of parchment to sit decades before it was used to write the Quran on. And second, that kind of throws the whole thing out of the window, doesn't it? Radiocarbon dating only tells us when the animal whose skin was used to make parchment died. There could have been absolutely no connection between the date of the parchment and the date of production of the Quran. For economic reasons, we wouldn't have assumed that someone had a piece of parchment made and then it sat in storage for decades before it was sold or used. You would generally want to use up your inventory before getting restocked, whether you're a seller of parchment or a scribe who makes copies of the Quran. Economically, you wouldn't want to keep parchments in storage for decades, but that assumption, while fairly reasonable, is merely an assumption. We don't know anything about who made the parchment, who bought it, and who used it. We know little to nothing about the economics of this whole operation. To quote a young magician named Gob Bluth,
I heard the jury's still out on science.
The Birmingham manuscript is a famous one. It was dated around 2015 by the University of Birmingham to have been produced between 568 and 645 CE. I remember back then there was a huge media circus around it because 568 is of course before the Prophet was even born. Ex-Muslims and evangelical atheists were having a field day with it. They were arguing with everyone. It was so annoying. Anyhow, this so-called Birmingham manuscript has only 2 leaves. Later, 16 more were identified to be sitting in the National Library of France, making the total to be 18. However, the Quranic scholars also don't believe that this Quran was produced as early as radiocarbon dating tells us. It was likely produced around the late 7th or early 8th century. The range given by radiocarbon dating covers around 77 years, which includes the entirety of the Prophet's lifetime, which is from 571 to 632 CE. Any year in the range is equally likely as any other year. Based on just the carbon dating result, if you say that this manuscript was produced in 632 and I say that it was produced in 580, we're both equally right or equally wrong. Now, what's interesting is that the Birmingham manuscript seems to be following the Uthmanic standard, which was established around 650, which falls like 5 years after the radiocarbon dating range. So, what's going on? Again, we don't know. It could be one of 2 things. Either radiocarbon dating results are wrong, or that a lot of the features of the Uthmanic standard were established before Uthman's official standardization. Both of these things could be true. Codex Mashhad is one of my favorite manuscripts of the Quran. It's very expansive and covers over 90% of the Quran with only a few folios missing. What's interesting is that it's certainly an Uthmanic Quran, but it doesn't follow the Uthmanic arrangement of the chapters. Like I mentioned before, various people and cities had their own traditions on how to study, arrange, and recite the Quran. Some of these traditions either came from or were attributed to companions of the Prophet. In Kufa, which is now in Iraq, the Codex of Ibn Masud was prominent. This Quran follows Ibn Masud's arrangement of the surahs, while the text is Uthmanic. There's many hypotheses for why this is. For example, it could have been that someone who supported Uthmanic standardization wanted to meet in the middle, so to speak, with the supporters of Ibn Masud and arranged the chapters according to Ibn Masud, but kept the Uthmanic text. Another interesting thing is that the Quran claims to have been written by Ali ibn Abi Talib. The deed of Waqf, which is a document that states that a particular item was donated and cannot be sold, states that this manuscript, which was written in the handwriting of Amir al-Mu'mineen, meaning Caliph, Ali ibn Abi Talib, is being donated to the shrine of Ali al-Rida, one of the Shia Imams. This waqf was likely made around the 12th century, but the manuscript itself is much older than that. It has been radiocarbon dated to between 660 and 772 CE, which seems to agree with its paleological content. See, in this case, the radiocarbon dating result covers 112 years, and that's good. That's what radiocarbon dating is good for. To use it to place a manuscript within a range of less than a century seems too optimistic and privy to errors. The Corpus Coranicum is a project out of Germany that's been studying and analyzing Quran manuscripts to find out what they can tell us about the early history of the Quran. They've been radiocarbon dating some of the oldest manuscripts of the Quran in existence. The results of 14 of these manuscripts have been published by Michael Marks and Tobias Joachim in their radiocarbon dating of Quran manuscripts. This is how they compare with what scholars who have studied these manuscripts by their texts date them as. You can see that the earliest four, according to C14 dating, show the most disagreement with paleological and codicological analyses. These four also use the Hijazi script, which is older than the Kufic script. The Tübingen manuscript and the subsequent ones are all in the Kufic script. Later Quran manuscripts, as you can see, mostly began to have agreement between C14 dating and what scholars think. The paleological range of the Birmingham manuscript is almost entirely different than the C14 range. The C14 range for the Sana'a palimpsest consists of 43 years, which is too short a range for C14 dating to reliably give. Nevertheless, it's dated by scholars to the early 8th century. Similarly, MSORFOL 4313 has a 46-year range given by C14 dating, which only slightly overlaps with the range given by paleological analysis. You can see that other than Birmingham, the first four manuscripts, the ones with the greatest discrepancy, have very short ranges given by radiocarbon dating, which is a problem itself. This is too precise, and radiocarbon dating isn't very good at placing an object within a range of less than a century, as I said before. This table is quite limited because it does not include the latest data from other labs, and it treats all folios of a manuscript as a singular unit. But for the purpose of this video, it's good enough to show that indeed there is a lot of discrepancy between the Quran manuscripts' radiocarbon dating results and their paleological and codicological study results. In his book, Quran of the Umayyads, Francois de Roche writes that he had two Qurans whose dates were known, carbon dated. One of them is known as the Quran of the Nurse, which is quite a famous manuscript because of how well preserved it is. That manuscript has a deed of waqf. The waqf on that manuscript dates it to 1020 CE. However, the radiocarbon dating results for it said that it was produced between 871 and 986 CE with 95% probability. The most probable year was given as 937 CE. You can see that the original date of production stands some 4 decades away from the end of the range. The most probable year is off by 83 years. Similarly, another Quran manuscript bore the date of 907 CE but was radiocarbon dated to between 716 and 891 CE. The date of production stands only 18 years away from the end of the range. However, the most probable year, 791, is around 116 years from the known date of production. In another case, Francois de Roche mentions 3 manuscripts that were dated by the deed of waqf to the 11th century, but were dated through paleological analysis to the 9th century CE. In this case, the 2 labs that tested them agreed with each other and confirmed that the manuscripts were indeed produced in the 9th century. The point of this video is not to be anti-science in any way, of course. The point is to say that radiocarbon dating is not some kind of end-all solution to the problem of dating antique organic material. It is a tool, and like all tools of analysis used to study historical objects, it must be used in tandem with other tools to understand things more clearly. I often jokingly say that history is such a subjective study that even when science interacts with it, history brings it down to its level. Radiocarbon dating seems like some kind of objective scientific method, while scholars looking at markings and the spelling and the illuminations on a manuscript of the Quran seems subjective and unscientific, at least in the minds of the general public. However, that's a very incorrect perception, as we've seen. Media generally picks up the results of radiocarbon dating without telling people its limitations. People want to confirm their own biases, whether it's Muslims who want to say that the Quran existed in the Prophet's lifetime, or evangelical atheists who want to say that the Quran predates the Prophet. None of them bother to listen to scholars who frankly have been talking about this forever. It's just the general public that considers it gospel. Science is supposed to be about empirical evidence and trying to get a fuller picture, but too often does science get the same treatment as religion. People cherry-pick the evidence that they want to prove what they believe without wondering, is this the whole truth?